everybody, to the BS and Beer Show. BS stands for Building Science. Tonight, we're talking about one of my favorite topics, building diagnostics. So I'm super excited to have Doug and Randy here to talk about this awesome topic. Emily Matra, I'm an architect in Maine. Tonight, I am having a lovely glass of Pinot Noir because it is cold here. And so I've moved on from beer for the time being. We want to encourage people who are also doing local groups. I know some of you guys are doing local groups, meeting regularly on Zoom. So we want to encourage people to continue to do local groups and form local groups. We just ask that people don't copyright the name. Otherwise, we want to really encourage you to meet with the people who are local in your area, especially since we get a smidgen of flack, maybe from Travis mostly, about being New England centric. Sorry. So, forming groups in your local areas is awesome because, you know what's prevalent in your markets. And we want to thank our partners, our media partners, Green Building Advisor, and Fine Home Building. So thanks for joining us tonight for Building Diagnostics. Kylie, if you want to describe how it works.
Sure. Yep. You'll find that.
And what are you drinking? What are you drinking, Kylie?
Oh, right. Mike, thank you. I forget every week. And it's never anything exciting, which is why I forget. So I'm drinking a blackberry seltzer water, but thank you. Let's see. So the chat box, you probably are all very familiar with this format by now, but it's at the bottom of your screen. And if you want to make comments or ask questions, please make sure that you click the all panelists and attendees button. And if you're on a mobile device, you might have to do that each time you make a comment. And if you only see one person on your screen and you want to see all of the panelists, then make sure that you click on the speaker or gallery view. And the agenda for tonight will be an introductory presentation from Doug. Sounds like he's got a game on tap too. A panel discussion and some questions from the audience. We will wrap up at 7:30. More exciting news. I do have a special announcement to make on behalf of Fine Home Building. The summit is coming up October 26th through the 29th. We did this last week, but I'd like to do it again. The first 25 people to email fhads@taunton.com with Kylie sent me in the subject line will get a free admission to the 4 days of presentations that are happening. That's a $200 value. There's 15, I think, speakers lined up. It's going to be information packed and awesome. So really good deal. Do that. I'll put the email address in the chat box with the instructions. I think I said everything I'm supposed to say. Kick it off to Mike for more announcements.
Yes, I'm Mike Maines here in Maine, and I am drinking a Baxter Brewing Stowaway, or I was. You have to come back to me. Sorry about that.
Mike, did you just spill that back?
I managed to spill a can of beer.
Oh, I'm sorry, buddy.
I think it is not touching any electronics, so I will push on. All right. Announcements are Passive House Maine's Fall Forum is October 21st to 23rd. The Maine Indoor Air Quality Council Forum is October 27th to 29th, which happens to overlap with Fine Home Building Summit. Vermont's Sion House Tour is November 7th, which is tours of 4 high-performance homes, including ones designed by Friends of BS and Beer, Bob Swinburne, and another one built by Unity Homes. D.C. chapter of BS and Beer is doing a group on social justice and the building sector. We'll put a link in there to sign up. You email Nick Berger at Yahoo. And yeah, I think that's good for now.
Well done, Mike. I like that recovery. I have had more than a few mishaps on here. I think you recovered very nicely. Although I'm sorry for your loss. We call that alcohol abuse here in the Midwest.
Yes, it's still half there, so we will.
That's a recovery right there. Well, it's on to me. I'm Travis. I'm in Kansas City, which I consider the mighty, mighty Midwest, and I like it just fine, Graydon. So I'm drinking a Boulevard Brewing Tank 7, which is a delicious saison, and I'm drinking it from a Retro Tech koozie in keeping with tonight's theme. I get to introduce our guests, which is a great pleasure because I like both of these guys. I've known Randy for a while. He's a great friend, and I have just gotten to know Doug a little bit better and was actually chatting yoga with Doug earlier this week. So I have a legitimate connection, and I'm proud to introduce first Doug Horgan, who is Vice President of Best Practices at BOWA in Washington, D.C., a premier custom and remodeling firm. But he asked me not to read his bio because Doug is an important guy who does a lot of presenting, and he knows the importance of brevity. So I'm going to give you the short version, which is that Doug made problems for 10 years, then found and fixed them over the last 20. And he'll tell us lots more about his building experience here in just a moment. But first, let's introduce Randy Williams, the Northern Built Pro. Randy has been in construction for 25 years, 10 of which were spent working as an electrician. He still holds a journeyman electrician license. And in 2009, he moved away from general contracting into a career as an energy auditor. Today, in addition to conducting energy assessments, he does some building science and energy design work and keeps a hand in carpentry field as a subcontractor and occasionally as a consultant. And he's currently working on one of my favorite projects, the Code Minimum House. Randy, I'm excited to hear from you tonight. Thank you for joining us.
Happy to be here.
And I think we're going to start off with a presentation from our friend Doug. So that kicks it off to you, Doug.
All righty.
I didn't give you guys a chance to introduce yourself and what you're drinking. I'm sorry. I'm always so terrible.
That's all right.
What are you drinking, Doug?
I'm drinking a gin and tonic that's non-alcoholic, made with Lyre's Dry London Spirit.
Nice.
That sounds fancy. You got anything in the can there, Randy? What do you got?
Yeah, coffee.
Nice. Now we're ready. Now we can have Doug's presentation. Thank you.
Okay, cool. Thanks, everybody. And let me just get this going. So I want to talk about some diagnostic tools that I use. And then I have this this game, which I think should be a somewhat amusing way of introducing some of the things that I've learned to do wrong over the years. That's the whole concept. So, so I want to start with the things I carry every day. Actually, let me put the cat down here. I have this case that I bring with me everywhere I go. I don't know if you can see that in the little picture, but it's just a good way to keep things organized. I think it looks more impressive than when I used to just randomly fumble around and get out stuff. So and there's a way I can lock it, which anyone could break in 10 minutes, but you can't break in 1 minute. So I feel like it's safer against like your old smash and grab. So I carry all the stuff together. The first tools that I started with were a humidity meter and moisture meters. And the two of those can actually find and solve many, many water problems. And water problems, I would say, is probably the majority of what we end up working on that I pull out tools for. Usually there's some mystery about where it came from, what's going on, and you got to track it down. And these are tools that can help you understand if there's likely to be a sort of a humidity level problem. And if there's a liquid water issue, a moisture meter is a great way to track it. And I will show you a lot more about that when we do this game. The other tools that we ended up getting, an infrared camera, which is really a terrific tool in a lot of ways, and I will talk more about that specifically. I got a blower door and a manometer and did the BPI education, which was fantastic. I strongly recommend it to anyone who works in the trades. It's really opened my eyes. After 20 years of thinking I knew what I was doing, I realized there was a ton more stuff that I just wasn't even aware of. And being able to use the manometer and the blower door has enabled me to solve many, many problems that were just complete mysteries to me before. So that was great. And then the last thing that I use a lot is data loggers, which are just little things that record stuff over time. And I'm almost always using temperature and humidity data loggers. And those allow me to solve problems that only happen intermittently, or solve issues that happen when it's really, really cold at 4 a.m. and I'm not at that person's house. So those are super helpful. And if I'm not mistaken, Randy, you have a lot to talk about on blower doors, manometers, and data loggers, right?
Not so much with data loggers. I don't use those, but yeah, the blower door testing. And,
well, I find the data loggers, there's a lot to learn about those too. So maybe we'll bring that up on another one, but I'm going to skip over it for now. So here's what it comes down to for me. In addition to finding it really helpful to use these tools to find problems, it really helps explain things to people, to clients, to insurance companies, to architects, to all the various folks who are involved with your project. So I think getting data together is really useful. Here's just a quick thing that happened with me. Some clients called us. They had this weird thing where they had water in their basement, and they just weren't really clear where it was coming from. And I pulled out the infrared camera and was able to take this shot where you can see, not only am I able to see the wet area, you know, sort of everything in here, but I can see that there's more here, and it sort of feathers out as you get away. So I can kind of tell where the water really is in this picture. And sure enough, it's from the, you know, the leaky water heater, which is what you'd expect. But the reason that they had called me, I think they kind of were pretty sure it was the water heater, but they also had another issue in the same room. So when we turned our head around, there's this little drywall seam that's split up here. And I think maybe some water had dripped out of there. And then I was able to use the thermal camera and take a look at that area. And so the seam is kind of this area here. And then it connected back to this much darker, sort of, in my opinion, much wetter area that none of us were aware of. You couldn't see that with the naked eye. So the infrared camera is really terrific because, you know, evaporation is a cooling process. Anything that's porous and wet will be cooler than the things around it that are porous and not wet. So it makes it very easy to do a quick scan and come to understand things really quickly about where you have a real water issue going on. It's useful for other stuff too. I mean, they're kind of expensive to buy the kind that we got. It's, you know, I got one of these real FLIR cameras. This was about $2,000, which was quite an expense, but I'll show you in a second. I'm using a $200 phone version, and I think it's just as useful. So these are very within reach for almost anyone. So anyway, knowing that there was this spot in the ceiling, we ran upstairs. We can see there's this wavy floor area. That's a sign. It's right outside of a bathroom. I'm thinking already, oh, there's something wrong in this bathroom. The wallpaper's peeling off in the bathroom. I'm starting to think, well, maybe there's something going on upstairs. I don't know what's going on. But scanning that bathroom, no issues in that one. So I went over to the one on the other side of the wall, and sure enough, there I found another wet area. And it turns out that it was a leak from the supply of this toilet. So again, just the infrared camera makes things quick, real quick. But I didn't have one of those for 10 years. I was finding and fixing moisture problems just using a moisture meter, and those are really fantastic. I started off with one that didn't have lights or sounds, and I found that the kind with the lights and the sounds allow you to work much faster because you don't have to face it. You don't have to have a light on it. You can just run across surfaces really fast. When they're wet, they beep loud, and you'll see that again in a minute. It also somewhat works on various different surfaces and materials. I've had pretty good luck, even though I get screwy readings in natural stone and tile. More than half of the time, there is an area that has much higher readings, even though I get weird readings all over the floor. They're weird and much higher in the area that turns out to be wet. So even though I don't think this moisture meter is designed to read masonry and tile, it seems to work most of the time. And then another tool that I've used frequently is a pin moisture meter. Those can be more accurate, and there are situations in which you want the utmost of accuracy. Whenever there's another party involved who's going to be mad at you if you screw something up or try to make it look like you screwed something up, it's good to jab your pins in there and use the calibration setting. You know, make sure that you have everything set up correctly. Take pictures. There's going to be an insurance claim on this water leak that someone had in their house. So I drew a drawing on the floor of what areas were wet and wrote down the moisture content of the wood so that when their insurance company tells them they didn't need to remove this plywood, they have more evidence that they should have. So that kind of thing happens. It's super accurate in wood, the pin moisture meter. A lot of people don't like you poking holes in their wood, so I use a pinless meter 99% of the time. So again, with the infrared camera, you can find the wet stuff. It just allows you to see things that you weren't aware of. All of these spots that are dark in this picture were away from the original leak area, which was actually back over here on this side. So a really nice tool for that. Okay. If anyone has questions on that, throw them in chat and someone can read them off to me. Okay, so as I said, I've made a lot of mistakes. It's possible I've made more mistakes than almost anyone you know. So in the spirit of that, you know, learn from the mistakes of others. You can't live long enough to make them all yourself. I'm going to play a little game here with us. So the idea of the game is to actually, let me go ahead and switch my share here. Hang on a sec. We'll bring up this instead. Okay, so we have 8 samples on here, and we're going to use 4 different methods to look and see if they are wet or not. So the goal of the game is there a moisture problem on this sample? And I think if you want to play along, you can write up a thing like this with a line for each of the samples. And the 4 different methods we're going to use are the infrared camera, pinless moisture meter, pin moisture meter, and then a visual inspection. And at the end of it, we'll be able to say, was there a moisture problem or not? And I heard that Fine Home Building is giving away a free 3-year subscription to whoever comes up with the right answers. Did I hear that right?
That sounds right.
No,
I'll say yes.
That isn't right at all. That isn't right at all. Okay. So, but go ahead and play along, and let's hear what folks think. I think at the end, I'm curious to hear in the chat how many you got right, ended up being right, and how many ended up being wrong. So there's going to be 32 answers, I guess. The last answer will really be the end of it, the correct answers. Okay, so I'm going to start with an infrared picture here. Sorry, this is definitely amateur hour. Oops. That's fun. There's a major delay. Oh, okay. I'm in the complete
That's in keeping
place.
with
Okay, I'm sorry. We're getting there.
Yeah.
Does this even count, though? Oh, for God's sake. Okay. Okay. Almost. Mess up with my lighting here. Okay, so yeah, that's me. All right, based on what you're seeing here, we're going to write down which of these is wet based on an infrared inspection. I'll give it a few seconds. You can shout it out in the chat if you want. Put down the ones you think are wet, and don't put down the ones you didn't. Okay. All right, I'm going to get out my moisture meter. If you need another look at this, let me know, or try to do a screen cap. I'm going to move on. I'm going to move the camera out of the way. The thermal camera. Okay. All right. So my other tool that I have is the moisture meter, and this one's a Protimeter Survey Master, or Protimeter. I actually literally don't know how to say that. Got a couple of tips for using this. First of all, every time I turn it on, I do this just to make sure it's in the right mode and it's working, because this is a pin and pinless meter, and if you're scanning stuff when it's in the pin mode and you're trying to use the pinless, you're not finding anything. Believe me, I've definitely done that. The other fun thing with the pin ones is I think I've got it down to 1/3 of the time I poke myself when I get out the pins. They're really dangerous. The other cool thing I figured out is you can use one of these painting tools, and you can strap this to it with a Velcro strap, and then you can attach that to a painter's pole, and you can use that to reach really high, difficult to access areas. And this this painting tool actually has a flexible handle, which actually works out really well. It allows you to really flatten this against the wall the way that you really need to. And we work in a lot of these houses with 8, 9, 10 foot, you know, much higher ceilings and walls. So it's really helpful to be able to access those remotely, as it were. Okay, so I'm going to use the pinless mode, and I'm going to test sample number 1. Here we go. All right, can you see the number on there? It's not beeping.
No, can't see the number.
Oh, really? Okay.
Can you read it?
75. I will read the numbers. Thank you for letting me know. Okay, so 1, 75, no beeps and no numbers. Oh, you know what I meant to do first? Let me just show you. This is drywall with my hand behind it. So you usually get nothing or else the first green light on dry drywall. Wet drywall, depending on how wet it is, you can get a really high number. So I've pinned the meter on that one. 999 is the highest number it does. And on this meter, the numbers are arbitrary. They don't actually, they're not trying to represent percent of moisture content. A lot of meters do represent percent of moisture content, and they're designed to work on wood, but this one does not. Okay, so moving on. Number 1, no light. Number 2, oh, can you hear it beeping? It's very excited. Yeah, so we're at 180. Okay. Sample number 3. How did that look in the infrared, sample number 3? Anyone want to shout that out?
Dry.
Look dry.
Look, yeah, no sign of moisture, right? Oh man. I'm in the 700s here, 800s. I'll explain that one in a minute. All right, sample 4. How did that one look?
Dry.
All right. I'm in the 100s again. Interesting. Okay. All right, sample 5. 170, 195. Actually, forget, what did sample 5 look like? Did that one look like it was cold or warm? Room temperature.
Cold.
Cold.
Wet.
Okay. All right. Wow. Sample 6, I'm 500, 600. And what did that one look like?
Dry.
Dry.
Okay. All right, we're ready for 7. 7 is 500, 600 something, bouncing around. Okay, and then 8. I'm in the 500s and 600s again. Interesting. All right, does everyone have their answers for all of those? Now we're going to do the pins. Actually, I'm going to use the pins that I'm less likely to poke myself with, and which should allow you to more or less see what the thing's doing a little bit better. Okay, so number 1, let's see. Okay, so you can see no reading at all. Okay, number 2. No reading at all. Number 3. No reading at all. Interesting. All right, number 4. Wait a minute. Okay, we got a little bit of a reading. Wow, I may actually be having some tech. Oh God, I forgot to change the setting. All those were wrong. This is exactly what I'm supposed to do. This is
That makes
perfect.
it all
Now you
feel
know
better,
what life
Doug.
is really like, making mistakes. See, I'm supposed to test this by using my skin to make sure that I've got conductivity. I forgot to because it's a big show. I'm screwing everything up. Okay, so back to number 1. All right, this is saying 14.0% moisture. And this meter is trying to read a wood moisture content. So if these are wood, that's what it'll give us. Okay, number 2, 25 in the red zone. Number 3, 76, way into the red. Number 4, 18.0. Okay. Okay. I hope I didn't go too fast through those. I felt bad because I did them all wrong. All right. Number 5. $20.4. Interesting. Number 6. 11. Number 7. Yeah, it's reading 100%. Pin the meter. All right, and number 8. 32%. So very high. Okay. Now we've done 3 different methods. How do we feel about these? What do we think about number 1?
Doug, you
No
gotta
idea at
edit
this
the
point.
numbers. Yeah,
No
I
idea?
keep up on my numbers, but I have to say I felt like there was conflicting data. Did I get conflicting
Yes.
data, or am I just wrong?
There's conflicting data for sure. Yeah,
For a
different
real
tools.
reason.
Yeah. Well, so let's think about what these things are measuring. What's this one doing right now with the pins?
Good.
Yeah.
Giving us an
Conductivity.
actual measurement.
Oh, right.
It's measuring conductivity between the 2 pins. Wood has a predictable amount of conductivity based on how much moisture is in it. So the more electricity goes between the 2 pins, the higher the reading the computer gives you. But you can see you can fool it by anything that conducts electricity reasonably well will make the meter think that it's in a wet piece of wood. When you look at the other method, the pinless one, that's kind of a density meter, really. It's a really good one. It's very sensitive, and it works very well. But you're really not reading water per se. You're just reading how dense the material is, more or less. And then what's the infrared measuring? It's reading
energy.
Yeah, it's reading the right. Yeah, exactly. Actually, it's reading infrared emissions, which normally is the temperature, but not always, as we know. And actually, I learned something new about that today, which will be fun to show. Okay, so let's do the visual inspection. Oops, no wonder that was so high. Okay, so what do we got here? Sample 1. What do you think all that stuff is?
Looks like mold.
Yeah, it's mold. It's mold, and I brought it right here into my own house. So this piece of drywall reads dry, but when you look at it, you see there was a problem. So we actually get this a lot. A surprising number of people call us 3 or 4 weeks after they had a flood and ask us what needs to get fixed. Everything might be dry by all of the readings. Okay, this one, number 2, is a piece of TPO over a piece of wet plywood, wet drywall. The TPO is roofing material, right? It's completely impermeable. So moisture is not evaporating out through this and cooling it off. Even though the drywall behind it is quite wet, the TPO is not allowing it to dry, allowing it to cool. So with infrared, it doesn't look different. This is a piece of drywall. I put a piece of plastic over it, actually a Ziploc bag. It's soaking wet, but again, with infrared, you're not reading that it's wet because there's no evaporation going on. And this has happened to me when people use fancy like oil-based faux painting on their drywall. Sometimes it doesn't dry. The wet parts don't look any different at all because there's no evaporation going on. Now this is these are pieces of oak, and I tried to get them good and wet today. So this actually happened to me once. I pulled out my infrared camera like the second day I had it, and someone said they were worried their floor was wet, and I looked at the floor with the camera and it didn't look wet. You know, it all looked the same. Let's see. Did I get that in there? Yeah. Yeah, so I finished half of this board, the upper half, and I didn't finish the bottom half. So again, there's no moisture escaping through this finished surface. So even though the board is basically about the same wetness the whole way through, although you can see I had that, I had a piece of thing on there. I was trying to keep it wet for the meeting. You know, it's basically about as, oh, I'm doing this with the thing in the way. It's basically about as wet on each end, but the end with the finish doesn't look cold with the infrared camera because there's no evaporation. I think I beat that dead horse enough. All right, this one we're getting these interesting, you know, somewhat high readings, and the drywall itself is actually dry. It just has a piece of duct metal behind it. So I'm actually reading the metal. That makes the meter go crazy. The drywall itself, not that bad. So that's another thing that I've definitely done wrong. This is really happens in condo buildings a lot. They use, besides the metal studs, they use all kinds of metal, like it takes the place of blocking. It's like strips of metal where you're gonna attach stuff to, trim and cabinets. So you're scanning along and all of a sudden it seems like you hit something, but all you're hitting is the sheet metal behind it. All right, then sample, what are we on now, 6? It turns out EPDM makes moisture meters go crazy. So this is dry, but the meter is reacting to the EPDM like it's soaking wet. So again, you gotta watch out for what materials you're working with. Both of these roofing things can screw up the readings that you'd be getting. This one, there's a piece of metal foil in it. And again, that's making it go crazy. It's just a thin metal tape, but I put this one in the front. So when we hit it with the pin moisture meter, the pins bridged across the metal and we got a maximum reading, right? We were basically completely conductive across the foil. So it's another thing you can do wrong with a pin meter. They used to make foil face drywall. I've only run into it once or twice. But if you do and use a pin meter on it, you're gonna think you're going crazy. Okay, and then again with 8 is wet wood with no finish, so you can definitely tell with all the methods because it's cool because it's evaporating off the top of it. Okay, how'd we do, everyone?
You stumped the chumps.
That's for sure.
I was not tracking with you. Did you get all these, Emily? You're the expert here, right?
I didn't get them all right, for sure, but I knew that he was fooling us too.
Yeah.
So
well, it was kind of rude, wasn't it?
No, it was on purpose because I've done this. I think one thing you didn't talk about is have you done it during the day on a sunny day and the whole wall looks warm and you're like, yeah, hey, this looks great. And then you go back when it's dark and it lights up like a Christmas tree from the outside. That's fun.
Couldn't agree with that more. In fact, the thing I learned today that was kind of cool was that I had to glue this piece of paper. Oh, I already switched my share. I had to glue the piece of paper over the foil because it turns out that Tyvek is fairly transparent to infrared. So whenever I put the infrared on this piece of foil that when it was showing, all I was seeing was a reflection of whatever was on the exact opposite angle was being reflected into the infrared camera. So I built this thing outside on my driveway and I would shine the camera on it and I'm seeing that foil was reading completely cold because I was looking at the sky, which is freezing cold. And then I knew when I brought it inside, I had like computers, lights, monitors. I had no idea what I would get. So I actually glued the piece of paper on it to block the infrared. You learned something new. All right, I hope that was at least mildly entertaining.
It was very entertaining.
All right. So, and obviously you weren't supposed to get it all right. And every single one of these are things I've done wrong. So please don't feel bad. Just I hope it helps. Helps you in your practices when you're out looking at this stuff. Okay, should I stop sharing? Randy, you ready to go?
Yeah. I am. I don't have a presentation. I just have a few things I want to show and talk about. So I do things a little bit different than Doug. I contract with a couple of power companies. So I end up with high bill complaints. And a lot of the stuff I end up having to work with is electrical. So I'm using clamp-on amp meters to try to figure out electrical draw, or I'm using a watt meter to determine what power is being used. So when I get into a house, I'm looking for three things. There's three different things that always happen in every house that I'm in. Number one, there's a problem with the house someplace. You know, I'm thinking that could be one of the problems. Number two, the other problem, it could be a problem with the equipment in the house. And number three, this is often too, there's a problem with the homeowners living in the house. You know, what are they doing in there? Do they have 100 plants affecting moisture? Do they keep the house at, 65 and they're 60 in the summertime and 80 in the wintertime? You know, I'm in a heating climate, just so you know. I'm in climate zone 7. I have 10,000 heating degree days, or heating degree days in the season. So I'm quite cold. Those are, that problem with the people. It is very common. Not cleaning the air exchanger. That's I see lots of problems with that. Not getting enough air exchange. Too much humidity. That'll build up humidity in the wintertime. So that's kind of when I first look at a home. That's the three things that I'm focusing on. My main tool is a questionnaire. I'm asking. What's going on in the house? What kind of equipment's in the house? My questionnaire right here. Did they notice any humidity on the windows in the wintertime? Are they comfortable? I want to know, the heating system, of course, the water heater, stuff like that. So I'm spending some time asking questions before I even start testing a home or looking at the equipment. As far as some of the other equipment I use, Doug's got the one camera that he uses attached to his phone. I've actually got one of the smaller FLIRs. It's a C3, quite handy. It's affordable. I have got to work with the $20,000 FLIR cameras. They are amazing, very, very cool pictures, but way outside what I need. Another thing that I use a little bit is I've got this is a wearable carbon monoxide detector. Every once in a while I'll get into a house, even though I'm working with electricity. Occasionally I run into something that I see a backdrafting on a venting water heater, natural venting water heater. You'll notice a little bit of debris on top of the water heater itself. I'll crack this out just to make sure that I don't have a spillage issue. What else do I got? One other thing, laser measure. When you're doing blower door testing, figuring out the volume of the test or volume of the home, that's very common for me to use to speed my process up. A little later on, I want to talk about the home that's behind me. That's kind of a case study. I visited the home, but I haven't really tested anything yet. I'm waiting for winter. Do you guys want to go through that now, or do you want to wait till later?
No, go ahead.
Go for
Yeah,
it.
why don't you go through that now?
Okay. So I'm going to get out of the way a little bit here. This couple called me in. It's a family. There's 4 or 5 people living in this house. Last winter, this is a house that's 1930s. It was built in 1930s, which is kind of old for my area. Right through here, they indicated that last winter they had water coming out of the siding. So my first thought is, okay, they did something to the house to change it. Obviously, it hasn't been doing that since 1930. Well, they brought me up to this upper level, which was originally an unconditioned attic or vented attic space. The windows weren't there. You can see a little bit of a discoloration in the siding right there. That's a patch. They had a vent in there. This entire shell was, or it was all spray foamed, closed cell spray foam. Right down through this wall, the entire ceiling, everything. They wanted to turn this into a bedroom. One of the interesting things I found out is that I asked them, well, when did you insulate this? They said February. Doing closed cell spray foam in February in Minnesota probably isn't the best idea. That wall, the roof, that could have been zero. Very cold, and of course spray foam doesn't adhere very well to that at those temperatures. But I really wanted to get in and do some testing on this house. But I want to see what's happening this winter first before I do that. I want to see because he said it was leaking right underneath the window. Well, the spray foam comes all the way down to this area. Why is there siding coming out so low or so high? He's thinking it's higher than I'm thinking it is. But I want to test that. So my first thing would be a blower door test. I want to do a blower door test on this house. I can't. This house is loaded with asbestos. It's got vermiculite. The walls are loaded, so I can't do any kind of testing. So that kind of limits me. What's my next course? What do I want to do next? Well, I think I'm going to be taking some of the building apart, to visually test what's going on. I think it's the only way I'm going to be able to do it. So part of the other reason why I want to wait till this winter to get a visual before I start taking things apart, and then hopefully take it apart this winter so I can see where's this frost or where's this water accumulating. Another interesting thing with the house, the homeowner thinks it's balloon framed. So all these walls, I've got a connection from the basement up. When this was a vented attic, of course, this whole thing probably was leaking air the entire, since it was built almost 100 years. But it was able to clear when I got up to this area. It didn't form frost. It was cold enough up there. It was able to, and enough air movement through that any moisture that did get up there was able to clear. Now, of course, with the spray foam, it's blocked off. Again, it's been a couple weeks that I found about this. It was a couple weeks ago that I looked at it. It's new to me. I'm looking forward to actually testing this one because exploring this one to figure out what's going on, because I can't test it. It's kind of an interesting project and problem. That's really all I've got for now.
So, Randy, is it an optical illusion that there are red parts like down on the bottom, or is that where the water is actually coming out?
It's paint peeling. So there's up right in here, through here, and then actually all along this fascia board, there's paint peeling off and that's what they actually call the painter in to fix it. And the painter realized that there's some other problem with this, and he's the one that gave him my name, and that's why I came in to take it.
Did that paint start peeling after the spray foam? I mean, that quickly, or was that an existing problem?
The spray foam is 3 years old.
Okay.
So and they don't remember it peeling before then, but it could have been just not that bad. I think they accelerated the paint issue. Yeah.
Was there anything unusual about the weather this winter?
This last winter we had a lot of it was cooler and a lot of snow. A lot of these houses, the older ones, especially in this neighborhood, had a lot of ice dams, big icicles hanging off of them. This house apparently has some of that, but again, I don't drive by it every day, so I don't recall.
Randy, with the vermiculite, somebody else mentioned, is it possible to do a positive blower door test, or would that be safer than a negative, or you just would rather not go there?
It would be, but I'm not comfortable. We've got all stucco, and I'm not sure what's going to happen if blow it back into the house. Yeah, well, I'm not worried about damaging the finish at all, but I'm worried about just stirring the stuff up and then ending up with some of the fiber into the house, and I want to avoid that.
Especially if there are any kids or elderly people that live in this house.
Yeah, and there's 3 kids, so yeah, that's one of the rules with doing any energy assessment or energy audit is try not to damage the house while you're conducting it. Sometimes you have to dig into it. That's one thing, but yeah, you definitely want to hurt anybody or cause any issues with the house.
So after you do your physical inspection, what are you going to do next? What's your plan of attack?
Talk with the homeowners, and if it's what I think it is, and again, I won't know until I test or until I take things apart, but if it's what I think it is, I personally think that they should turn that space back into a unconditioned attic space, keep it cool. To get into remedying, especially if it's the basement's finished or partially finished, each floor is finished. Do we tear the siding off? Do we tear the stucco from 1930 off? Do we completely gut the interior to try to stop the air movement from going through the walls, the exterior wall cavities? I think it's going to be way easier just to turn that back into an unconditioned attic, vented attic space.
Did you have them test the vermiculite?
This comes from the builder that was doing the improvements on the houses. He told the homeowners that it's in there.
Yeah.
And if it's vermiculite, Minnesota's we have a lot of asbestos in the vermiculite that is present in Minnesota. So I would just assume that it's there.
There's a lot of false positives on vermiculite testing anyway, or false negatives. I don't know. So usually I just say, take it out or leave it alone.
Yeah.
It's safer that way.
Yep. And I have had, when I was working as an electrician, I had a remodel job that we were working on where I had to cut an outlet into a wall. And the wall at one time was an exterior outlet. I drained 8 foot of cavity onto the guy's floor while he sat there and watched. You can't stop it. It just starts coming out, and you just end up with a big pile on the floor. Travis is laughing. He's probably had that happen.
I've been there. It is a super disaster. And there's no,
How do you clean that up?
It only happens when a homeowner is in the room talking to you while you're working. It never happens when you're in an unoccupied home and they brought you in to do it. It's always like, oh yeah, what else did you do this weekend? Oh shit! No. It's a disaster.
Yeah.
That should be number one question on the checklist. Have you seen any shiny rocks?
Yeah.
There was a question about furnace. So Patrick asked, did they change out the furnace to sealed combustion? And then I wondered, you might have mentioned it, but are there bath fans or does the basement seem damp even though it's finished?
I asked about the moisture issue because in the wintertime, if they have any kind of a moisture issue, it's prevalent. We see it on the windows. Our windows become dehumidifiers when it's 20 below. I don't, unless you have a really good triple pane. I didn't notice bath fans. They do have sealed combustion, so it is drawing outside air for the forced air furnace. Actually, it was a boiler in this one. Yeah.
Dryer vents and range vent hood and
the house is leaky enough. I'm sure if I were to test this, it would be 7, 8, 10 air changes per hour. With the blower door running, plenty of air. It's not tight enough where I would worry about exhaust only devices in the house.
Yeah, and is there any chance? I know I tend to go right for the complicated, vapor movement, hydrothermal action when, a lot of moisture issues are bulk water. And Helen had asked if it was a slate roof. It kind of looks like it might be a slate roof. Is there any chance that this is a bulk water issue that is just showing up because it's getting trapped behind the spray foam?
I think if it was bulk water, we'd see an issue with something in the summertime also. Some kind of damage on the interior. The house is plastered, so there'd be some sort of a damage interior. They did indicate that there was a small leak at the chimney that you can see right here. It's leaking around the spray foam coming into the house, but it's very minor. It's something that they're aware that they have to get fixed, but it is minor. This is a shingle. It's an asphalt shingle made of. It's like
Grand Manor type. Yeah.
Yeah. Very cool house. It's definitely not an open floor plan. You walk in there, and there are walls all over the place, but very cool old house. It's a shame that that a contractor didn't realize that, hey, putting the spray foam in here probably changed the way the house works, and you might have a problem. And it's hard to think that way. I have had other contractors in my area say that they would go into a house, especially the upper levels, they tighten, do a remodel, tighten the upper levels up, and we'd start seeing water between the levels, at that rim joist area between the third or the first and second stories. What they did is they just moved that pressure plane from the ceiling down to the second level where there were leaks, and it was able to leak at that point. So it's hard to think of all this stuff when you're remodeling, or even when you're testing, what's going on. It's hard to keep track of all that.
Yeah, I mean, it's hard enough on new construction to ensure you have continuous control layers, and just you want the control layers, the four control layers, as close to each other as possible, because when the more you separate them, the more chances you have for problems. And
Yep.
and so an old house may not even have a continuous air barrier. Certainly doesn't have a continuous vapor retarder.
I'll take new construction over trying to fix something like that any day.
Yeah. Yeah. No, that's good. I had a question back to a follow-up for Doug, was or a couple of questions. One is do you have any idea, this is really or an aside, but any ideas why EPDM sets off the moisture meter? Is it, I mean, just it's rubber. It should be an insulator. It shouldn't be conductive at all.
I mean, I know it's full of carbon black, which is conductive.
Okay.
The thing that I can't figure out is why the density meter goes nuts when you hit it, because
right.
But yeah.
Well, that's a related question is on the pinless meters. I used to have one that died, and I haven't replaced it, but it would scan about 1/2 inch deep, and I know there are others that will scan deeper. And mine had a little booklet where you would read the reading, and then if it said 11%, like it was normalized for fir, I think, and so like if you were testing maple, then 11% translated to 8%. So like it was related to density, but it was like density and conduction. And so is it really strictly density, or are there other properties going on? And do newer, fancier meters have that automatic conversion built in? Do you know?
So I'm probably someone else knows a ton more about this than I do. I do know our company, we have 2 or 3 of these that cost several $100s, but since then we've bought a number of them that are pretty inexpensive, like Home Center, $50, $80, Ryobi has one, General Instruments has one, and they all seem to work great. If you're looking for the part of the drywall that's wet, you get a reading here where it's dry, and then when it changes, you're on the wet part.
Right.
So that's the short story. All of them do have different settings you can use. Actually, this one doesn't have different settings. It never wants to say that it's giving you an actual wood moisture content reading in the pinless mode. I have had one that did do that, and you could adjust it based on the species. You type in the number of the species, and then it would do it like that. But anyway, I guess I'm really not actually answering your question. I know there are at least 2 different principles used in pinless moisture meters, but for the purpose of finding something that's soaking wet, they all seem to work great.
Right. So for diagnosing buildings that have an issue, they're okay. If you're trying to build furniture and you want really tight reveals, and you need to know is that stick 12% or 16%, then that's not the.
Well, I think there are woodworkers pinless meters. I used to own one of those, but it didn't beep and have lights, so it was kind of a pain to use in a dark closet. So that's my 2 cents on that. I do think those are supposed to be reasonably accurate as long as you don't have something under it and the wood's the right depth and all that stuff. Yeah.
Okay. And so as what this is a question for either of you, but just for your average builder, architect, or engineer, those of us who are not trying to make a living diagnosing these buildings, or it's not a focus of our job, but just we want to have a tool that we can show up with what's what should your average professional first tool in the kit, or is that too subjective a question?
If you're a new builder and you're concentrating on performance building, Jake Bruton's got a blower door. A lot of the builders are picking up blower doors. It doesn't have to be a brand new one, if you can find a used one, but that's going to give you a lot of information. Of course, you got to learn how to use it, and BPI is a great resource for that. I have taken BPI training. My first one was a regular energy auditing, a 5-day energy auditing training class, where we had hands-on. But there should be, even online, there's enough stuff on YouTube where you can figure out at least how to operate it and determine what it's telling you.
I know there's the Minneapolis blower door and the Retro Tech. Are there other brands, or do you guys have a preference over those two?
I'm from Minnesota.
Yeah.
I gotta think of
Minneapolis.
Minneapolis.
I have a Minneapolis too. I personally found all the little cup things in the Retro Tech to be a real pain in the neck.
Man, I think that at the end of the day, you can do great work with either. I know there's as many people I respect who love one as the other. I mean, I have a Minneapolis and a DG 700, and honestly, that is not the easiest tool to use. But no, they don't even sell them anymore, so it doesn't matter.
Doug, do you run software? Do you run a computer to run your blower door, or are you just using the DG 700?
So I have done that, but only on a couple of occasions. We don't do compliance type work. Long story short, okay. I'm using it to find problems, or to get a very general idea of where we are.
Okay.
Yeah, but so I have mine's new enough for that.
Okay. Do you do multi-point testing, or is it just single point? If you're looking for a problem, I'm sure it's just single point.
Yeah, I'm just doing single point. In fact, we work in really big houses a lot of the time. I'm much more often in can't reach 50 than multi-point, if that's a little bit inside baseball. But a single blower fan is not big enough to depressurize a lot of the houses I'm trying to evaluate.
Ouch.
To 50 pascals. In fact, I bought the D-ring when I got my set, and I didn't use it for 6 years. We finally did a house that blew under 1, and I used it for that.
Wow.
Yeah.
Yeah, some of that stuff comes in handy if you're doing zone pressure diagnostics. So if you're trying to figure out something, some of that, testing beyond that, we do multi-point testing as well for HERS rating. It's now, required. And I'm with Randy. If you're going into existing houses, have a carbon monoxide tester, just the little guy. That's a BPI thing, I think. Anyway, it's like you got to turn that thing on before you even go into a house and carry it around with you. Maybe not prevalent everywhere in the country, but Maine is probably still 80% fuel oil. So most people have some kind of combustion heating system.
Randy, have you had that go off when you're in someone's house?
No, I haven't.
No. I walked into a conversation between someone who worked with me and a client, and he'd run over there because their carbon monoxide alarm was going off, and they were in the house talking about it. And I walked in there with my carbon monoxide thing, and it just went crazy. It's so loud. Mm-hmm. I said, okay, out we go.
Mm-hmm. I have an idea.
Going back to that question, I think if you're just looking for one tool to learn a bunch of stuff about houses, these inexpensive infrared cameras like the C3 that Randy has is actually a terrific camera. These are inexpensive. They're kind of a pain because it's in your phone and it doesn't work with your case, and there's a lot of little dumb things about it, but it's every bit as useful as our $2,000 camera when you're in someone's house trying to find problems. The pictures aren't as nice, so if you're going to be an expert witness, you should get an expensive camera from what I hear, but it's really, really nice tool, and you can find out so much about a house with infrared. Really crazy.
Doug, can you share a couple of the mistakes that you've made in the years past that you now would never make because you've been introduced to these tools and they save you every time?
No.
Is there a good
I
example
mean,
of
I
that?
made a mistake today while I was doing this. So, no, I would never say that. In fact, if anything, I start almost every conversation with clients with, I'm not positive this is right, but I found a problem and it is enough to explain it, but there could be another one. I'm just not sure yet. Anyway, yeah, I mean, I've learned a ton about building houses better by seeing a lot of ways that they aren't built well, or which ways they fail. It's, you know, a lot
I
of
think
the things.
you really proved a point too, though, which is that, and something that Travis said, you know, the vermiculite thing only happens when the client is in the room. But I mean, I'm sure both you and Randy, as you know, they're talking to you and you're trying to do diagnostics at the same time, you are going to miss something or see something. Or I don't know if you guys have all heard the story. I don't know who tells it in which of the certification classes, but somebody had an infrared camera and they showed it on the wall and they're like, oh, you know, you forgot to put the insulation here. And the builder's like, really? Picks up a hammer and blows a hole in the wall. There's insulation there, but there was an electrical light on the outside and the light wasn't sealed. So then the person with the infrared camera had to pay to fix that hole the builder just put in the wall because we said there was no insulation here. And so they put a hole in the wall to prove to you that they did. So, you know, it's like, I didn't do it. I've just heard that story. So like you said, Doug, you always preface it with like, I'm not sure, but my diagnostic tools are indicating that maybe we should take a look at this area, further investigation. I don't know. So.
I mean, I've had two this year that, using all of this stuff on site did not get me there. And I had to pull out the data loggers just to figure out what the humidity situation was. And one of those, I probably won't know till winter. Kind of the same as Randy's saying, like if these things happen when in certain types of weather and you're not in that season, you just can't find it.
Okay. Can you tell us about the data loggers? What are the brands? Are they hygrothermal or what are they, wireless?
Yeah,
Are you paying for
I
the
love talking
monitoring?
about data loggers because they have allowed me to solve a ton of problems that I never could get close to before. I mostly use Onset, Hobo. Actually, here's one. This one isn't a glowing recommendation for it because I dropped it and it screwed up the screen. But it still works, so maybe that is a glowing recommendation. So it's just a little computer and it measures temperature and humidity, and you set the interval. I mostly use these for building and HVAC and humidity things, and I just usually leave them on 15-minute readings. And you can actually get too much data with these. You have to be a little bit careful with it. You know, like the British Health Service ran out of lines in Excel. I've come close to that on a couple of these things where there's just so much you're like, well, I mean, I don't even know how to graph this. But so they just record the temperature and humidity, and usually there's like a problem room, and then there's some other rooms that are fine, and there's a thermostat, and I put one at the thermostat and one in the problem room and one of the rooms that isn't a problem, and then I can watch this house behave during the hot afternoon or the freezing cold night and see what's going on. Sometimes we've had things like I got a house with some floor shrinking issues and we monitored the whole house and the outdoors up for a whole winter. So I got to watch the humidity levels in the whole house, and I used our internet connected ones. So I was able to call them and say, hey, something's wrong with your humidifier. And they ran down and fixed it. So that was kind of cool. But you know, that you can also use them for diagnosing HVAC issues. If you can put it on like 1-minute resolution, and you can tell exactly what the system's doing and not doing. That's useful with zone damper systems and some other weird stuff like that. And we have one that measures water flow. That's useful for there's a lot of water to water systems in condos, and they whatever, I don't know if we get into it. You can measure a lot of cool stuff. You know, Dan Kohlberg, who's in the chat, bought some wood moisture content readers that you can actually bury inside the wall, and they talk to a device outside. I think there's another brand called Sensor Push, which seems to be which is a little bit less expensive and does some different stuff from the Hobo ones. And then there's another brand. Someone told me that a cheaper version is the AccuRite brand, ACCU-RITE, and they make some inexpensive ones that connect to the internet. Oh, there you go.
Yeah, that's
I was gonna say I have several of those things that I spread out like in new construction last and
Yeah, I think
supply
I
them
got
to
one
clients.
too.
They're like $10 or $8. Yeah.
Right. So I
And
think they sell a set of these that are like 50 or 80 that has 2 or 3 of these and a Wi-Fi.
all of us nerdy people.
Yeah. So those are kind of fun to play around with. So worth a shot.
Can
Yeah,
I bring us back? Oh, go ahead, Emily. Sorry.
I was gonna say they're like $8 or $10 too. So you know you don't have to feel too bad about kind of spreading them around. We'll do that if
Those
the
data
first.
log?
No, I don't think so. They're just point. Probably some of them do, but
I mean, they could be down that cheap. I don't know. I bought a like a $25 data logger, and it worked just as well as the other ones, but had this really wonky software that I was kind of nervous about installing on my work computer, you know, stuff like that. So I'm sticking with the good brands of stuff, right? It's like random name that sounds cool. I don't know. It was not a very good experience. The device itself, no problem. So that's my 2 cents on this.
Can I bring us back around to, I guess, a little bit more high level? I mean, there's certainly really focused applications available for all these tools. And I think you guys both touched on this a little bit in your presentations, but since Emily started mentioning multi-point, and I don't understand how that works myself, the benefits of it. I would talk to Nathan Shirai at Installation Unlimited about it a little bit, but I don't really understand. He kind of showed me and I was like, oh yeah, that makes sense. And then it was gone. So would you guys kind of walk us through, everyone, can you walk the layman through, this is really the why you would do this test. If a client calls Randy and says, hey, I'm experiencing high humidity in this back closet, and I'm not really sure why, but my clothes are wet when I put them on in the morning, and I don't have mold in there, and I don't have a roof leak, and what's the first thing you pull out, and then where does it go from there? Like, I get that you have the questionnaire, and I think that would be really an excellent resource to start with. There was a great comment from Kurt in the chat about how observational analysis is really your best tool to start, and I don't think you guys are saying otherwise. This is just additional inputs to help narrow the focus. But I guess what would help the layman, or even the minor layman, like, I have some of these tools. I even have tools you guys don't have or didn't mention. I have an anemometer. You guys got anemometers? Nothing? Oh, I win the anemometer race. I lose all the other races, but that one's mine.
I have an ASIN flow finder too. So there.
You got me. Damn. That's
it's a
all right.
$3,000 anemometer.
Well, then I don't win that one after all. My field piece, I think, was about $300. So what I would like to know, though, is if you guys can kind of help us understand, if you're getting into trying to solve these problems, I want to know the if then, and then maybe that'll lead us to the multi-point, which I know there were other people in the chat that were like, wait a minute, why would I do that? What does that help me do? You guys talk, I'll shut up.
Well, maybe we should start with the multi-point. That's probably the easiest one for me. I use computer-controlled software to run my blower door. It's the easiest thing for me to do. I can do other things while it's doing its own thing. I don't have to mess with a dial or anything like that. So multi-point starts off at a pressure. So I'm starting off at 50 pascals, and it does a series of test points, each at a lower pressure. The fan reduces its speed to drop the pressure in the house. So it measures at 50, 45, 40, 35, all the way at, or 50, 40, whatever it is, but it gets down to 15 pascals, which is a very low pressure. Usually when I get to there, I have a problem if it's windy. I'm not moving the fan fast enough to overcome the wind on the house, and I get some bouncing pressures on the house, but it usually figures it out. And it ends up being, it's just an accuracy. The multi-point gives me a more accurate number, a more confident number of what the house is actually at. Is my understanding anyways of what the test does. And again, computer controlled, I don't have to mess with anything. It does its own thing.
That's not what Nathan explained to me at all. I definitely am thinking of something completely different. It had something to do with using a manometer during a blower door in a room that you close the door off of to determine X, Y, or Z. Doug knows what I'm talking about. What are you guys talking about? What am I doing?
Zone pressure diagnostics.
Yep.
Totally
That's the
different
one.
thing.
Yeah.
Never mind.
Way harder to do, which I totally understand why you were like, "No, wait, what?"
Well, that makes me feel a little better.
So I have two DG meters that I use. One will control my blower door, and I've got what's called a DG 500, which won't control my blower door, but I use that for doing pressure testing. So all it is you're holding your meter in your one hand. You got a hose connected to it. You throw the hose underneath the door, shut the door, and you're looking at a comparison between that room and the room you're standing in for pressure. So the blower door is running. The house is at minus 50 pascals or positive 50 pascals, whatever you're running it at. When you're standing in with that second manometer, you're at 0. It's relating to the room you're in. You throw a hose underneath the door, shut the door, you're going to get a comparison between the two rooms. So if I'm reading
the leak.
Yep. So for instance, if I read minus 50 in that room with the door closed, I know that room has got a window open. It's completely connected to the outside. If it's reading 25, I'm half connected to the outside, half connected to the inside. So it's just a relationship. The numbers, it's just a relationship between the two rooms.
So that allows you to basically track down the leak and narrow that to this is the room I'm going to
exactly.
Maybe this is the room I light my smoke pencil in or whatever.
Right. Oh, and you can do it to an attic too. I've got a probe that I can attach to my hose where I can shove up into the attic and I can see how connected the attic. You want the attic completely outside the house in most cases, at least in my climate. So you shove that probe up there and I should be at 50 pascals or minus 50 pascals. I should be completely outside the house. And if I'm reading 25, I know the attic is now connected partially inside and partially outside. There's a problem. We've got to find that.
Gotcha. So other than air leakage, what other things are you guys tracking down with these tools? I mean, obviously water leaks. We talked about the thermal imager and obviously the moisture meters they're checking for moisture. Right. But I guess the diagnostic tool gamut, it seems like you guys are using some of these like in conjunction. You're doing this and this with this to determine that. And I think that's real next level deep dive stuff that maybe is a little beyond the layman. But since you guys are experts, why not go there? Or continue to go there? I guess you're already there.
It's always working. Always working.
I was gonna say not necessarily, beyond the layman, like both Doug and Randy mentioned, I use my blower door with my infrared camera because that exacerbates the problem area. So that makes some things show up really easily. It can really help to kind of locate. Although at the same time, you can, it's not 20, the theory or whatever is like a 20-mile-an-hour wind on all four sides of the house at the same time. Obviously, that doesn't happen all the time. So you can exacerbate something that's maybe not much of an issue normally, but it does kind of help you track down some areas, especially ones that you can't really see. So like if you have a porch and the porch rafters are open to the floor framing system, which is pretty common, and you can't see that because the porch has a roof and they have a ceiling on the inside. If you turn your blower door on and the whole ceiling is cold, you can, you've located part of your problem. Or in manufactured housing, we've had it where the marriage wall isn't sealed and you turn that on and the whole center of the house is really cold. You climb up in the attic and pull the fiberglass back and boom, there's your 2-inch gap. And so using those two tools together works really well. Or I use my DG 700 with my pressure pan to test exhausts for ERVs and for BEF fans. So
nice.
You can only test the exhaust on an ERV. You can't test the supply. You have to have another flow hood, which is more complicated and has electronic parts and other things, which.
Yeah, and I would say manometers can measure really low pressure differences that can help you find weird problems. So I had a house where they had a summertime moisture issue behind window trim, and I popped off the window trim, and this window was sealed up really well. There was just one tiny little hole in the foam and the caulk, between the window and the jamb, but there was a jet of air coming out, and it wasn't a windy day, and I just couldn't figure out what was going on with that. And actually, let me go ahead and I'll just show you what I did. I got out my manometer, and I connected it to the outside, and then so the day I came back with the manometer, it was kind of windy. So I actually ran one tube out one side of the house, the red one, and the other tube out the other side. Ooh. It's the clear one, trying to average out the wind. And then, so then the green tube is going to outdoors, and I'm measuring that the house is 4.7 pascals negative compared to the outdoors. And then I used the blue tube, and I walked around the house, and I hooked up all these tubes and checked all the different rooms and stuff. I was trying to figure out what was going on. Ultimately, that one we tracked to they had an ERV, and the ERV inlet was completely clogged up. They'd sort of they put the inlet on a roof, and they sort of custom made a screen for it, which hadn't been looked at in many years because it was on the roof. So it was completely packed full of debris. So basically they were exhausting a lot of air and not bringing any back in. And it was causing air to want to leak in, which, in wintertime that dries things out, but in summertime it makes them wet, summertime here. So that was a thing first of all, I never would have thought of it before I went through the BPI training, and then I never could have found it without a really sensitive tool. I've also found that you can actually figure out problems with fireplaces. So here's one where after the fire went out, the smoke would come into the house because the house was under negative pressure. It's because the way it was built, it had a lot of leaks at the top of the house, and this was a short chimney. So they actually had a makeup air inlet for their range, and it was we kind of opened the basement window to see how much of an opening we needed to make the pressure even on the main level on a winter day, and that happened to be about the same as the makeup air inlet. So we gave them a manual switch for the makeup air, and they would just open the makeup air damper whenever they ran a fire. Problem solved. So but you don't actually necessarily, there are situations where you don't need a manometer. You can just use a sheet of plastic. So I'm trying to see if this fireplace is drafting or blowing the wrong way, and you can see it's sucking the plastic in. It's working great. You can just use little strips of plastic, hang them in a doorway or whatever, and you can watch it blow. You can use the handometer on the doors, even without, sometimes the HVAC system causes major pressure imbalances in rooms, and you can just open the door an inch and see if air's blowing on you or not. That'll tell you. But I use plastic about as much as the manometer. The clients are more impressed with the manometer though.
There's been some chat about BPI, and I'm wondering if there is maybe a go-to source for somebody who is not familiar with all these tools and wants to just get a basic overview of what to use and with what materials and what circumstances and what that information might lead you to. Is there that kind of a resource that you guys can recommend?
I think it depends on what you want to do. BPI is really, I think, has a lot to do with existing houses. So if you're going to do existing houses, you're going to either renovate or retrofit or do energy auditing. BPI is an excellent training source for that. Because, Doug was showing the plastic there. In your BPI training, you do worst case combustion appliance zones to figure out if you have negative pressure throughout the house. And so you can use your manometer for that, but you can use the plastic where you walk around and you put it in the worst case zone. You turn the bathroom fans on, you can use your blower door to simulate a 300 CFM fireplace being on, so you can do that. If you're doing new construction, I think HERS and Passive House are both excellent building science programs. Even if you never build a passive house or you never certify a HERS home, they're both excellent and have different requirements. So you learn different things in each of them. Those are probably the three biggest certifications that I can think of off the top of my head.
For certifications, there's also a lot of training that you can take. Like my area, Duluth has got the Energy Design Conference, which happens every year. It's a couple-day show where it's vendors, or the state of Minnesota even sends people talking about code requirements. But it's all high performance or better performing buildings. A class like that you can pick up quite a bit of building science. Construction instruction, you know, if we ever get the opportunity to travel again, going to, I think they're in Colorado now. It's a great resource to learn a lot of the building science and the tools that are used. And of course, reading the Joe Stiebrick's website, what's the name? Building Science. Yep. So you go there, that's just loaded with information. It's all building science. It's not so much testing, but you got to understand the building science before you can get into the testing. So.
I was much better at testing, and I could solve a lot more problems after I understood building science. But I definitely started long before I understood building science. I mean, you can find water problems with a moisture meter. You know, that is not rocket science. You know, they can be fooled, which I definitely learned all of these lessons by doing it wrong. But that's not that hard. And I'm not sure there's any classes on that. You know, you just buy a meter and start testing stuff.
Well, there'll be a GBA article overview.
Oh.
That's
of all these testing tools, because someone in the chat box said boroscope, which made all of us laugh.
Mm-hmm.
Anybody else have a boroscope? I hate that thing.
Yeah.
Enlighten us. Why do you hate it?
One, they're usually complicated to get into wherever it is that you want to look, and then you have to try to twist it and turn it so it's looking in the direction you want to actually look. And then half the time you either A, can't see anything because there's something else in the way, or you're not entirely sure what you're looking at because it's a tiny little camera and it's really close to whatever it is you're trying to look at because it's in a tiny little hole. So,
or it's upside down. You're looking at it upside down and you can't figure that out.
Or it's upside down.
Yeah.
You just roll over, Randy. You lay on the floor and you just roll over and it looks right again. It's fine.
Oh, that made so much more sense.
We have a 12-foot one, and it was way less useful than I expected.
Feet. Wow.
The thing it's good for is finding something wrong in the first 12 feet of a large pipe. And then you don't have to call the
Very
plumber.
specific.
Yeah. No, that's what I mean. Like I thought I was going to use it all the time. And
Catalyst has 2 boroscopes. We have little shorty Milwaukee that I used every day this week. And then we have one that we bought for a pipeline inspection. We actually had a weird job with peering involved. We were going to be doing some drilling into a basement slab that had, anyway, the point is we didn't want to jackhammer into the existing ground rough plumbing. The drains were going to be close enough to the action that we wanted to know if we were injecting this flowable fill into the space to pier this foundation that we weren't pouring it into the sewer drain, because that would have been really expensive. So we bought a nice teepee on Amazon and it served us really well. Those things come in handy for all sorts of stupid stuff. I got a cat out of a ductwork system with that thing. Tracked that cat for hours, and when I found the spot, I cut a hole in the side of the duct and pulled him out.
that's awesome.
It's not even a building science thing. That's just a cool story.
Travis, you're kind. I love it.
That's a good one. No, those are super useful, especially the ones with the tracking head. But they're like 10 grand for a good one. So we just hire people who own this. So I've been so tempted to try to get one of those but I don't know. It's nice. They usually come attached to a truck that can clear the drain too. So that's helpful.
Yeah.
My building diagnostics tip is when I was starting to learn about performance and building. I convinced a couple of clients to do energy audits, and I followed the energy auditor around and pestered them with questions, and they explained all kinds of things. And so the client spent a couple $100 and got a performance report, and I got a great introductory education. And
That's smart.
So if you're interested, I mean, it's inexpensive and useful enough. I would think that doing it on your own house, but just asking lots of questions, asking about the gadgets, like have them point the infrared at a mirror and see what bodies do in the mirror, and those kinds of tricks. But just I mean running the blower door and putting your hand, there's nothing like seeing it firsthand rather than trusting somebody else to just take care of it.
That really is the best way to learn. I think when I was doing a lot of energy auditing, I spent 3 months training with somebody else. So, find someone like Doug or Randy that you can follow around and just be an extra pair of hands and listen to them talk, because they probably, I don't know about you guys, but it's kind of like a running education for the clients who are walking behind you, so that you try not to miss anything. So you just kind of keep telling them what you're doing, so you keep yourself in order while you're going around.
I found that just doing that a couple times with our guys who get into the diagnostic and repair work, they kind of already know all the parts of the house, and you just have to put 2 and 2 together with, like, if water is still dripping 36 hours later, that's a plumbing leak. And if water only drips when it's raining, that's rain. And here's the 6 different weird ways I've seen water come in. And now that you think that through, you're good at it. So I actually kind of agree with that.
I took all the training. Go ahead, Mike.
Go ahead. Or no, just Shun asked, as a consumer, how do you know if an energy auditor is top notch or just acceptable? Is BPI certification, is that a good enough level? Should you look for a HERS rater? Do you just
I have thoughts.
You have thoughts. Don't trust anyone.
Are you going to share them?
There are ways to cheat the system in just about anything. So the training is excellent for sure, but there are good people who took the training. There are good people who didn't take the training. There are bad people who took the training who didn't know what. There are people who get complacent because they've been doing it for a long time, which is unfortunate. So I don't know how you evaluate them other than just knowing other people in your area who know people who do it. So, like, I don't do it very often anymore, and people call me and they'll ask for a recommendation, and I'll recommend the people who I know do a great job. So I don't know. You guys have any better advice? Call Randy. Fly him all over the country.
I was going to say, if you have a gray hair, gray beard, it's probably a good sign.
Good sign.
I mean, I knew a lot more after I did my 400th energy audit than my first. So, and I think that's how everything goes. But as you said, there's a lot of ways to do it well without that, and a lot of ways to do it poorly with that. So, Randy, I think you were going to say something earlier, right?
I was going to say my first experience as an energy auditor.
I think you may have frozen.
Uh-oh, we lost him.
Internet. If it's like at my house, I had to ask everyone to not stream till 7:30, and they might have said, "Oh, close enough."
All right.
So, yeah, I think Kylie, if you post about this, it would be good. We can all of us who have a bunch of diagnostic tools can write down what's in our toolbox.
It's a great idea. I welcome that. I
also have
will reach back out to you about it.
Combustion analyzer and a gas leak detector.
Yeah, I didn't realize you're such a gadget girl. You've got all kinds of things.
I've got all kinds of fun gadgets.
That's fun.
Combustion analyzers are really cool.
They are really cool. Although I don't know how it is where you are, Doug, but in Maine, the fuel board doesn't exactly like auditors testing their heating systems, especially if you have to drill a hole. They're not real fond of that.
Really? Wow. I don't know.
You have to have a special license, and
dangerously. That's interesting. Yeah, that makes sense. I don't know. And I've used that manometer to solve HVAC, like several weird operational problems with machines that, for whatever reason, a lot of pretty good HVAC techs don't have a manometer with them. And they, it's not, all I did was read the manual. It said hook up a manometer here and here and see what the reading is. But I was able to do that, and they just hadn't. So.
Yeah, when I was doing duct blasting, we did a bunch of HVAC. Oh, not as much duct work here, but yeah, it's pretty cool what you can learn with a manometer and a couple of, little L-shaped.
Right, static pressure, good one. Yeah. All right.
All right,
Cool.
folks, it's 7:30. I don't think Randy's coming back, which is unfortunate.
Yeah.
We can't say thank you.
He's
But
great. Yeah.
yeah.
Oh
We will
no, I just got a text from Randy. He says his power just went out.
Oh boy.
Oh, no.
geez.
He's definitely not
That's
coming back.
unfortunate. We won't be
Oh.
seeing him,
he's
but
not
I know
having
it was a pleasure to have him.
Freak October storm. Thank you, Randy, if you watched the replay. It was awesome.
Right.
We'll reach out to you guys afterwards. Thank
Thank you,
you, Doug.
Thank you, Doug.
Thanks, Doug.
I enjoyed the game. I
Yeah,
think
that was very clever.
I think
That
you
was-
should do a little recording of that and put it up, because that was
That's
a
a
lot
good
of
idea.
fun. And I think there
Yeah.
are a lot of people who would definitely benefit from
It's
it.
very lesson filled. Yeah.
Well, I learned those all painfully, so hopefully it'll help one of y'all avoid it.
How long did it take you to put that thing together? There's some work there.
I don't know, a couple hours. There was
Yeah.
I'll tell you the weird part is trying to keep the temperatures right.
I bet.
Like you can't make it
Okay.
yesterday.
Right. Right.
All right.
All right. See you. Thank you very much.
Thanks, everybody.
Bye, guys.
Thanks, everybody.
Good to see everyone.